Right, in this video I'm going to run through the answers to the first part of the past paper homework which I set, so just the first 3 multiple choice questions in this video. Question 1. Which of the following elements has the greatest attraction for bonding electrons? And you've got 4 elements here. The key to this question lies in you remembering what this phrase, another word for this phrase here, this phrase attraction for bonding electrons. So see if you can think what word means the same as attraction for bonding electrons. Right, hopefully you've thought and remembered that the word which means the same as attraction for bonding electrons is electronegativity. So that means the same as attraction for bonding electrons. Once you've realised that, it should be a fairly easy question. So we're saying which of the elements has the greatest attraction for the bonding electrons. That means the highest electronegativity. And what you should remember is that you can find the electronegativity values for the elements in the data book. You would just need to use the contents page. I think it's on page 11, so you can just look these up in a table. Now, what I would recommend doing with this type of question is writing on the electronegativity values beside the elements, just to make sure you're going along the right lines here, you don't make any silly mistakes. So lithium has an electronegativity of 1 or 1.0 if you want to write that. Chlorine has an electronegativity of 3.0. Sodium has an electronegativity of, I think, 0.9. And bromine has an electronegativity of 2.8. So this is just the Pauling scale, and like I say, I think it's page 11 of the data book. Once you've written down the values, nice and easy to see that chlorine indeed actually has the highest electronegativity value, so that's why the answer to question 1 is B. Okay, question 2, or question 4. I haven't changed the numbering of the questions, sorry about that. So this question says the diagram shows the melting points of successive elements across a period in the periodic table. There's a couple of clues here if this was part of a bigger past paper which would help to tell you about which topic the question relates to. So you've got this word melting point and you've got this phrase across a period. Across a period tells us that this is all to do with periodicity, about the trends in the periodic table, and this phrase melting point tells us that it's to do with structure and bonding. So the first part of this topic, if you remember, is about structure and bonding in the first 20 elements. That's what this question is all about. Okay, and the question says, which of the following is a correct reason for the low melting point of element Y? So before we even look at the answers, or the possible correct answers, what I want to do is figure out what element Y is. So we've got this graph, we've got melting point on the y-axis, we've got group number on the x-axis, and we can see that Y is in group number 5. Now it helps here to remember that higher is generally about bonding structure in the first 20 elements. So you're only really looking at the first 3 periods, maybe a little bit into period 4 of the periodic table. That gives us a good indication that Y might be able to have a think. What elements do you know that are in group 5 of the periodic table? And look at the periodic table to help you out with this. There's no reason not to. Okay, hopefully looking at group 5 you can see the first 2 elements in group 5 are nitrogen and phosphorus. So I said before, the phrase melting point tells us that this is about structure and bonding. So what I'd like you to think about now is what type of structure and bonding is found in the elements nitrogen and phosphorus. Okay, hopefully you're thinking both of these, and remembering both of these are covalent molecular substances. So nitrogen's a diatomic, it exists as N2. Phosphorus, we would only write the symbol P in equations or if we were just talking about phosphorus, but you should know that phosphorus exists as P4 molecules. So now that we know that these are both, Y could either be nitrogen or phosphorus, and that these are covalent molecular substances, we can then take a little look at the possible answers. So we're looking for the reason why covalent molecular substances have a low melting point, why either of these elements might have a low melting point. You can relate a couple straight away. So it has weak ionic bonds. That's definitely wrong because ionic bonds are strong. Ionic bonding is a strong type of bonding. Same with covalent bonds. That's definitely wrong because covalent bonds are a strong form of bond. C, it has weakly held outer electrons. That's kind of possible. We do know that weakly held outer electrons are a thing. That's if an element has a low ionization energy or a low electronegativity, it's got a weakly held outer electrons, but that doesn't really link into melting point. The key thing here is that phosphorus and nitrogen both have weak forces between their molecules. So remember, this is really, really important. I can't emphasize how important it is. When covalent molecular substances melt or boil, the covalent bonds don't break. It is the weak forces between the molecules. They're either known as van der Waals forces or intermolecular forces, and they are the things that break. Having said that, we will do a lot more on this in the next topic, so don't worry too much about that at the moment, but because we'll recap all of that in the next topic. Okay, and then finally, question 5. This is again testing your knowledge of bonding and structure in the first 20 elements. You must know the bonding and structure in the first 20 elements. So if I said, what's the bonding and structure in silicon, you could tell me straight away, covalent network. So we're looking for an element that contains covalent bonding and London dispersion forces. And the question asks which element could that be, so it's got to have both. So we'll just run through, again I would do this in an exam by actually writing on the paper. Boron has covalent bonding. You should know that boron's a covalent network, but it does not have London dispersion forces. So covalent networks don't generally have London dispersion forces because the covalent bonds extend throughout the structure. There's one exception to that though. See if you can think what the exception to that would be. So the only covalent network that has London dispersion forces is graphite, and that's an important one to remember. Okay, next one is neon. Think about the structure of neon and whether it has either covalent bonding or London dispersion forces. Okay, hopefully you're remembering, neon is a monatomic. It exists as atoms on its own. It's got a full stable outer shell, so it does not form covalent bonds. However, neon atoms can join together using very weak London dispersion forces. So neon has London dispersion forces. Sodium. Think about what type of bonding structure is found in sodium. Hopefully you're remembering that sodium is a metal, so it therefore contains neither covalent bonding. Metal atoms join to other metal atoms by metallic bonding, and London dispersion forces are nothing to do with metallic bonding at all. So actually we've already, by the fact that we've got 3 crosses here, we've already, by process of elimination, concluded that sulfur must be the correct answer. So just to confirm, think about what the bonding and structure is in sulfur. Okay, so you should remember that sulfur exists as molecules which have the formula S8, so there's a ring of sulfur atoms all connected by covalent bonds, so it does have covalent bonds, and that forms S8 molecules. But then, and you should remember this from page 8 of your notes, when we have molecules, all molecules have also got London dispersion forces as a weak force of interaction between the molecules. So sulfur is the only one of these elements that contains both covalent bonding and London dispersion forces. That's why the answer is D for that question.